Hello everyone. Welcome to today's webinar on saving energy through operations and maintenance improvements. My name is Dave Whitmore. All of PGE's seminars and webinars are in part sponsored by the Energy Trust of Oregon. We work together to make sure the concepts and recommendations you learn in our events are consistent across all of our individual programs and services. Okay, so before we dive into the webinar here, I'd like to learn a bit about you. So if you could, take a look at this slide here and tell me what type of equipment you have at your building or facility by marking the appropriate boxes. And if you don't actually work at a facility, then you might just mark the ones, the boxes, check the boxes that are of interest to you. And this will also give you a chance to use those tools, the annotation tools that Beth told you about. I'll give you a few minutes to do that. Looks like we got lighting interest, HVAC, all right, we got some compressed air. All right, if you're having any trouble with the annotation tools, go ahead and chat with Beth and she can help you out. Okay, some fans. Looks like some people with lots of different subsystems. Okay, thanks for your input. That helps me plan things out as we go through this. So the next thing I'd like to know a bit about is your role at the facility where you work. So same thing here. Use your annotation tools to let me know what you do, whether you're at an actual facility or not. So we have a maintenance manager, a facilities manager, a couple energy managers. Someone in finance. Okay, that helps out. All right, thanks for your input on that. So let me give you an overview of the agenda here. We're going to start out talking a bit about what O&M improvements are and why they're worth focusing on. And then I've got this talk broken out into different sections based on who might be tackling the opportunities. So there's some general ideas for different people at the site, ideas specific to maintenance or operators, ideas which really have to do with the timing of when you run equipment, and then ideas for management. Towards the end, we'll cover incentives and give you some details on that so you can see how to get some financial help on these projects. So for the first part, let's just focus on these first few bullets here. What are O&M improvements, why we should focus on them, and then we'll get into some opportunities. So O&M improvements are operations and maintenance improvements, and they're low-cost and no-cost changes that you can make. They're distinct from capital upgrades, which are usually more costly. They're cheap to implement, and you may find that you're doing some of these already. Why do we want to focus on them? Well, quick success, quick energy savings. There's often other benefits that come along with O&M improvements. You might have improved reliability, labor savings, improved product quality, or a safety component to your projects. You can often do them without having to get multiple levels of approval. They're good ways to get the most out of your facility, your equipment, and your staff. And then this is an important part here. You can get incentives from Energy Trust of Oregon. And Energy Trust is unique in this regard. Not all demand-side management programs offer incentives for O&M improvements, but the Energy Trust does. They've been doing it for some time. So why focus on them? I've got a table here that'll just show you a little bit about the persistence of cost savings. With in this case, the example is a 5 kilowatt reduction. And you can see that, as time goes by, these savings really start to add up. It's with a year, you're up to $2,000 per year, and then over a decade, $22,000, all for that original 5 kilowatt reduction. So they do add up, and if you can tackle a bunch of small things, they can really accumulate and give you some good savings. So let's jump into some actual ideas. This one, these are general ideas that could apply to really anyone at a facility. And the first one is just simply to minimize loads. In this picture, I think you can see that there's clearly some heat loss from this building. Having the snow on the roof there gives it away. Another example here, these are door heaters. And these heaters at this facility, we're using 8% of the facility energy use. This is a refrigerated facilities. And the heaters were there to prevent frost buildup on the doors. They were running continually, and the measure here, the opportunity, was simply to cycle the heaters. Simple thing to do, very good savings. Another example for minimizing loads would be, in this case, it's with a compressed air system. And I've marked the compressed air line in this picture. And there's a photo eye right there that I've just circled. And what was going on here is the compressed air was running continually at full pressure to keep the photo eye clear. And so the upgrade was to add controls so that the air could be pulsed just when it was needed. And then the other element was to reduce the regulator pressure to 30 pounds. Really good compressed air savings there on that one, and simple to implement. This is our second idea here, and this one is broad. It's eliminate leaks. This could apply to like heat leaks, steam leaks, leaks like in a valve or in a trap. Water leaks are common. If that water is heated or cooled, you can get a double bonus by reducing the leak, because then you save energy on your pumping, and you also can save energy on the heating or the cooling. On the compressed air side, we'll cover a number of examples that fit into this, but compressed air leaks are common. They're generally excellent opportunities with short paybacks. You could look at replacing components of the system. Sometimes you can even isolate part of your system that's not used at certain times, and that way you avoid feeding the leaks for that part of the plant. The third idea is simply to turn things off. It's amazing how much this one comes up. It could be lights, motors, or production machinery. You might be able to do it on the weekends or at night. If your operation has changed over the years, you definitely want to look into this one. You may be able to consolidate some of your equipment or your operations and turn part of it off. What you should be asking yourself is, what makes up your base load? What's the stuff that's running all the time, and does it need to run? That's a good way to look at it. And it really takes, just thinking about how you've been running things, if it's been the same for a long time, and considering whether you could change it. The fourth idea here is to use energy when and where you need it. And in this photo here, there's some light fixtures that are, back behind this stack. And so they're obviously not doing that much for you. Now, obviously in a warehouse, the stacking arrangements can move around where you have the racks and so on. But if you've got it set up and it's going to stay that way for a while, you might consider turning off some of the fixtures in this example. And I want to emphasize that this is just one example of where you might look at where you're using the energy. and when you're using it. But this is broadly applicable. There could be other systems where this applies as well. Here's one where we had a bunch of lights on a loading dock. There's no trucks here. You know, they're all just you know, sitting there with the lights on. And so the measure here was to, you know, use occupancy sensors, turn them off when they're not needed, if that's possible. The fifth idea, and this one again is kind of broad, is to really make the most of your control systems. You know, you want to use them as tools. People tend to get control systems set up and running and then leave them. And you shouldn't do that. You should look into what it's doing for you. You'll learn about the capability of that system. They're an excellent way to view your system operations. You know, connect with your control system vendor, get their help to learn more about things. Seasonal adjustments are often overlooked. You know, do you really need to run things the same way throughout the year? You know, if you've got equipment that's affected by ambient conditions, then you might be able to change how you run things. And you want to really be careful about buried set points. If you're not that familiar with the control system, you may not know, you may not even have seen the screen that has the set point on it. So dig into that and make sure you really know what's going on. These kinds of changes they're virtually zero cost. So, you know, a lot of them are. So they're well worth looking into. The next one here is to try to get rid of your manual overrides. And we've got kind of a dramatic example here in this photo. This is a refrigerated space, and these boxes here are blocking a photo eye, which is keeping the door open. So in this case, you know, the cold air from the refrigerated space was just, you know, there's a lot of heat infiltration. So, you know, obviously you want to get out of that kind of mode. There might be other things you've done that aren't as, you know, that don't jump out as strongly as this one, but other places where you've got manual overrides. And a few examples I've got here on the left are, you know, look at how if your sequenced equipment is in local mode, when it really should be in remote mode. And then another one that comes up a lot is a handoff auto switch. If a switch is in hand, what does that mean? You know, what's the energy implication of that?
Dave, I have a question about that last part. Why would somebody have the controls in the hand position over time?
Okay, thanks, Beth. That's a good one. One example of that where you might see it would be like in the case where a VFD, a variable frequency drive, is installed on a piece of equipment, and it's set up in auto so that it's going to slow down and speed up that equipment, that fan or pump or whatever it is, based on some, you know, set point. And it could be, you know, you might have someone who's not comfortable with that speed changing in that way, because in the old days it just always ran full speed, and they might go and switch it from auto to hand. So you want to look for, you know, if you see that, you should investigate why that's the case. Is there an issue with the equipment, or is it just because it's more comfortable to run it that way? And in the case I've given there with a VFD, it would definitely have energy implications. So that's one example. Thanks, Beth. Okay, let's get you guys thinking a little bit here and using your annotation tools. What I'm looking for, I'd like you to share an example of how your organization has made one of these changes. And there's a couple ways you can do this. You can chat with Beth and you know, just give her your ideas and she can share them with us. Or if you want, if you're feeling bold, you can ask her to unmute you, and then you can share your example. So I've got the 6 ideas we've covered so far. Take a look at those and give us some examples. If you're not at a facility, maybe share one that you've seen elsewhere, one that would be good to share with the group. I'll give you a little time to think about that.
Dave, one idea that I've heard at previous seminars that I've sat in on is sometimes folks will, it's idea number 3, the turning things off. They'll discover that their maintenance staff is leaving lights on overnight, and so they change the contract to make that something that doesn't happen anymore.
Yeah, that one. I mean, that's one that comes up a lot, and it can be, as dramatic as like a large warehouse, with a significant electric load that's running, where the lights are running 24/7. Something like that, you could go and put in occupancy sensors so they're shutting off whenever they're not needed. But a simple first step would be just to shut them off manually when you don't need them. And that might be, it could be like all weekend or, certain other hours during the week. So that's a good one. That's a common one. Any other ideas coming in, Beth?
No, I don't see any. Folks, if you have any things that you've been doing at your organization that you'd like to share, or any ideas you want to get more input on, please share.
Okay, so you guys can, feel free to chip in with those ideas even as we move along here. I'll give you some more time to think about it. Okay, so let's now cover some ideas that are specific to maintenance staff and then operators. So this one has to do with energy efficiency, just through keeping things clean. And this picture on the left here, a lot of people ask me, is that real? Yes, it is real. That's a pump screen. And you can see, plugged in a major way. What we have here on the right is this is a condenser. It's an evaporative condenser for a refrigeration system. And if this equipment were working properly, what you'd have with the water here is that you'd have a much better spray pattern over the tubes, which would give you a better distribution of the water, better dissipation of the heat. And in this case, the nozzles are plugged, not working well. And it's having a significant effect on the condenser operation. So probably no surprise to you guys, but if equipment's maintained well, it often will it'll use less energy.
Dave, why would the filter look that bad? Is that indicative of something else? Yeah,
no, that's a good one. People ask that as well. I mean, there's clearly something wrong upstream of the pump here, where there's some kind of primary screen there, a filter that failed. You obviously would never want this much debris to get anywhere near the pump itself.
And Dave, one more question that came in from an audience member.
Okay.
Do you, before you're done with the ideas, could you go back over idea number 1 again, minimize loads?
Yeah, you mean review number 1 again?
Yeah.
Is that what you're looking for?
Yeah.
Sure. So number 1, why don't we just flip back to it? So I've got 3 examples here for number 1. Just find the right slide here. So this example is where you've got a bunch of heat loss from a building, and that's obvious from the, with the snow melting on the roof. This one was a refrigerated facility where, excuse me, the door heaters were being used continually at this facility. And the heaters are there to prevent frost buildup on the doors. And those heaters were using 8% of the facility energy use, enormous amount. And the opportunity here was to cycle them. And you could still prevent the frost buildup with some cycling. And then the third example I gave was a compressed air example, where the compressed air was running continually at full pressure to clean a photo eye. And I've got the compressed air line marked there with a line, and then the photo eye marked. And the upgrade was simply to to add controls so that the air could be pulsed right when the photo eye was needed and the regulator pressure was reduced as well. So whoever sent in the question, thanks for that. And if you have, if you want more clarification on it, just let us know. I'm going to get us back to where we were here in the presentation. Okay, so we got through that example. The next one is minimize pressure drop. And on this one, what you want to think about is the pressure drop that you're looking at, will it affect the system set point? So as an example, if you replace some piping in a compressed air system and reduce the pressure drop in that system, but you're unable to lower the discharge pressure at the air compressor, it's not going to save you anything. It needs to translate to a lowered set point, where the equipment's running. So think about it in those terms. Try to tackle the ones that will save you energy, or that will save you more energy. Replacing undersized components, that's a common one. With a compressed air system, for example, you might have a filter with a lot of pressure drop, and that's what this last point talks about. If you're going to be switching them out every year or two, go with a good one that has a low pressure drop. These ideas here would apply to pumping and fan systems as well. So here's an example. I picked a compressed air example, give you some numbers and just show you what this pressure drop reduction would translate into. And in this case, we're talking about a 5-pound reduction in the pressure drop. This is a 1,000 CFM system. This number here, the 0.5% per PSI, is a standard reduction in power per PSI. And we've got the size of the system here. This is just a conversion of CFM to horsepower, and then we convert the horsepower to kW. 8760 means it's running continually. Here's the energy rate. And then what this translates into is $2,600 per year. So if you go out and find, you might have a bigger system where your savings would be even higher. You might have a system where you can do better than the 5 pounds. So go out and look for those if you have compressed air. You could do the same kind of thing with a pumping system, for example, and save on your pump energy use. The next idea is to fix or replace equipment that's not working well. And this list, I put a few things down. It could be way longer. But think about equipment you have that's there to save energy, but it's turned off. Maybe like a VFD that you're not using fully. Worn out equipment that's not performing well. If it's worn out, it's not performing that well, but doesn't have much of an energy implication, maybe that's not the one you tackle. But if it does, then go after that one. Failed equipment like valves or regulators, measuring your pressure or temperature, what have you, in the wrong place. Manufacturer defects, having a fan motor burned out. Some of this stuff towards the bottom here, we're getting into capital upgrades. But I think you get the idea that you want to look at that equipment that's not working the way it should and consider what effect that has. This idea is a good one. It's basically to calibrate. The example on the right here is it's just showing you a current reading on a fluke meter. But the concept here is that you want to be sure your current transducers are calibrated right. Pressure gauges, here on the left we have a couple. They're sitting there at atmospheric pressure. One of them's down near 0, but the other one isn't. There's something wrong with that one. Think about motor current capacity indicators on like compressors and so on. You want to try to do this on a set schedule where you're calibrating. Here's an example to give you an idea of what might happen if you're not calibrated. This is a refrigeration compressor. It's actual data with power on that axis and then capacity on the x-axis. And in this case, what was going on, was that you can see that the power was reaching 100%, but the capacity, oops, sorry about that, capacity was only getting up to about 90%. And the reason that was happening was because the transducer was reading incorrectly. So the machine thought it was fully loaded, but it was not. They were only getting 90% of the actual capacity. So this kind of thing could have energy implications and production implications. Another idea, again, these are for operators mainly, would be to consider if you can run a smaller unit. Is there something smaller that can handle the job? You again want to look back on whether your operation has changed over the years. If you're running at more of a lower production rate in part of the plant, then consider this one. It's closely related to load reduction. And a big thing that you want to think about is this last point here. Can you ride through some short-term blips? And that would be, a classic case of that would be like a load-unload air compressor that unloads. It runs unloaded for a while, and then it shuts off. Well, can you shut it off? How long do you have to wait till you shut it off? And when you do shut it off, your pressure starts rising, starts declining. Do you need to start up a new compressor right away, or can you ride through things a little bit and make it through and not end up just cycling that machine on and off? The picture here is kind of extreme, but we've got this smaller 5-horse compressor, whatever it is, and then some larger Solairs here on the right. But think about which one you're running and whether you can go smaller. This graph, this will give you an idea about part load option, and this gets a little bit complex. The example I've set up is it shows the part load efficiency of screw compressors. And what you've got here is an ideal curve down here, which is where your power and your capacity, they kind of just scale linearly together. As your capacity goes up, power goes up at the same rate. That's ideal. Best thing you can get, closest thing to that would be this purple line, which is speed control. Next best is load unload, where the compressor is loading and unloading. The light blue one is where you're throttling the machine and then you unload it. And then the dark blue is pure throttling all the way down, which is the worst. So as these lines get up higher on the graph, your power consumption is greater for a set capacity. Okay, so I want to give you an example here, a little quiz to see how you're grasping this. So let's say you have 2 air compressors. They're both 100 horse. One's load unload, and then one's a variable speed machine. And during the week you use them both, but then on the weekend there's not much going on. You only need about 50% of one of them. So which compressor should you run in this example? Give you a minute to think about that. You can chat with Beth, or if you want, go ahead and mark it on the slide. Use your annotation tools. Pick which one. Okay, we got someone picked the VFD machine. Any other guesses out there? A couple people on that one. All right, someone checked load unload. Okay. In this case, you would want to run the variable speed machine. On the graph here, you can see 2 circles. The bottom one, right there, that's where you'd be with the variable speed machine, the purple line. The one at the circle on the top shows you where the load unload machine would be. So the VFD machine's running, about here for power whereas load unload is a little bit higher there. The difference between those is your power savings. So you do want to go with the VFD machine in that example. Okay, let's give you one that's a little tougher. What if you're, same thing, same 2 compressors, but now your load on the weekend is 90%. It's almost all of one machine. Which one do you want to run now? Go ahead and mark it on there. Okay, we got guesses on both sides. Load unload, load or VFD. I think the person, whoever's got the green marker there has got things figured out. It really, in this case, it wouldn't matter. It's a little tricky here, but you're way up here at 90%, and you can see that these lines all kind of converge. So your power use is going to be pretty close to the same. So if you've got, a machine, you got a compressor, air compressor, it's running load unload. You're considering upgrading to the VFD, and it's up at 90%. It's very steady all the time. That's not an upgrade. That's not the place you want to look first to go save energy. If it's swinging around a lot up and down, then yeah, for sure, try to upgrade it. Okay, let's move on.
So Dave?
Oh, sorry.
Sorry, before you move on, I had a comment from an audience member for idea number 11.
Okay.
And that was about switching to smaller equipment, I believe. And this person says, sometimes smaller equipment is less efficient than bigger ones. Check the efficiency at the point of operation versus the charge. I don't know if you had any comments on that.
Yeah, that's a good point. I think we might even have a slide on that a little later, but that person's right, is that I mean, this graph is a kind of clarifying what they're saying, where if you, let's say you had a 100-horse air compressor and you're able to run it where it's pretty loaded, and then you've got another machine that's larger and it's going to end up being partly loaded. You need to consider what the part load implication is of what you're running. And this, in particular, if you've got a number of machines and they're sequencing, where you're running them in different combinations, then you really need to think about this. But in general, if equipment is more loaded, it's going to be more efficient, right? If it's up higher, closer to being fully loaded, it's going to be more efficient than something that's part loaded. But if you've got, 2 different pieces of equipment and you're going to end up with one fully loaded and the other part loaded, you still do need to look at, where is their efficiency? One just may be inherently very inefficient. So you do need to kind of have the big picture view of it. I would, and stuff like that, I'd get with your, you can connect with your PDC at PGE or, the manufacturer of the equipment and take a close look at how it's running. So let's move on to the next part here, which is on timing when you run equipment, and then management. The ideas for people who are in management. So number 13 here is to minimize equipment idling time, and that would be, I kind of touched on this earlier, but avoiding delays when you're shutting equipment off. That would be that, that air compressor example where it unloads, and how long does it run unloaded before it completely shuts off. Occupancy sensors, that's a big one. How long are the lights going to stay on after the last person walks away? And then this bottom one is kind of complex. It's consider running batch processes, intermittently, rather than run all that equipment, in a continuous way at a light duty. See, maybe I'll just do a batch and then shut things off, and just have less time where it's idling. Another classic case would be where there's a shift change, and the equipment's all left on, it's kind of idling, and then it's brought back up. Well, maybe you can turn it off in between shifts. This idea is to simply to do things only when you need to. And the example I've got here with this picture is this is a time clock which was being used to start a defrost on an evaporator coil in a refrigeration system. And whenever you see something like that where it's a time clock and the equipment's running at a set interval, you should think about whether does it really need to run at that interval. And in this case, maybe based on product loading or time of year, you could adjust the frequency for that defrost. You should really look at anything at your site that's running on a fixed schedule and just rethink it. How long has it been running that way? Does it have to? The next one is to do things at the most advantageous time. So, reducing evaporation losses by irrigating in the morning. I'm sure you've heard about that one. Queuing up the activity, the things you're going to do to avoid peak events or avoid overloading your system. Nighttime air changes in a warehouse. That's a good one, tied into the timing. Got a few ideas here for management to consider, and this first one ties into standard operating procedures, SOPs. You really want to think about those legacy standards that have been around for a while. I've got a few examples. Vacuum levels on a paper machine, your space temperatures, that's a common one. Humidity levels. Think about what you really need, and then what are the risks versus the trade-offs? And again, you get help from your PDC on what the energy implications are, and try to tackle those things that are going to save you more. And while we're on the topic of SOPs, a lot of the changes I've been talking about here today, if you make them, then you really should go and you want to revise your SOPs as part of making those changes. And that'll ensure that people keep operating in that new way. So here's another chance for you to give us some ideas. What I'm hoping for here is, you could do one of two things. The way I've listed it is share an example where you could make one of these changes. I'd also like to hear about any cases where you have made these changes. Maybe you've had success with one of these. And it's just these 4 ideas here that are, a little more complex than some of the earlier stuff we covered. But think about equipment idling time, doing things, when you need to, at the most advantageous time, and then your SOPs. I'd be particularly interested in if anyone's done some SOP revisions.
Dave, while we're waiting for people to give us their ideas, I wondered if you thought about where in these ideas employee behavior would fit in.
Among the ideas that we're showing here right now, you're talking about?
Yeah, or previous ideas. So you mentioned things, Rethink Standards for management, but how people use the equipment and what the people that aren't management, the operators, affects your...
Yeah, good question. The SOP example is one that fits into that very well. By rewriting those SOPs, you're rewriting how you're going to run that equipment. A lot of these, there's some of them where you're going to go in and change, like I gave a control system example where you go and change a set point. So, as long as that set point's left where it is, then you've taken care of it. It's going to happen. It's not one where you need to continually, look at people's behavior. But some of these other ones have a big behavior element to them. We talked about shutting equipment off, like the case of the lights in a warehouse. Well, you're going to have to check back in on that and make sure that it, it continues to happen. You can, if you have like regular team meetings, that's an excellent place to discuss this stuff. and then you know, to ensure that you're still doing them. So we have a few people have marked, like, you know, minimize equipment idling time or SOPs and so on. Did any ideas? Did you get any ideas that came in through chat?
No, not yet, but still time.
Okay. Well, you guys, we got a little more time here, and you guys have a chance to think about that and you know, let us know if you have questions or ideas. So now I want to cover incentives a little bit, and we've got, you know, a few different options for you. As I mentioned earlier, Energy Trust of Oregon, you know, very strong incentives for these types of upgrades. For custom O&M projects, you can get 8 cents per kilowatt hour or 40 cents per therm, up to 90% of the project cost, which is really incredible. I mean, that you can get paybacks down to, you know, literally within a few months with that kind of incentive. To get the 90% of the cost covered, you need to implement within 90 days. Your PDC can help you out with that, with you know, what you need to do to take that route. The other way to go is with a more comprehensive offering called Strategic Energy Management. These are, you know, longer-term forms of support where, you know, Energy Trust will work with you to build an energy team, implement numerous changes. They've been doing this for years, and there's lots of ways they can help you. The incentives are 2 cents per kilowatt hour or 20 cents per therm, and you get, you know, a higher level of support there over a longer period of time for strategic energy management. You do need to apply before starting the project. So I think I said at the beginning of the webinar that a lot of this stuff, you know, you may be already touching on it. So I'd encourage you to investigate the incentives. Okay, let's do a quick summary of what we've covered. And we talked a bit about why we should focus on these kinds of improvements, you know, what they are, and then, you know, broke things out by, you know, by the type of person or the, you know, by the role at a facility who might be tackling the upgrade. Covered incentives a little bit. And then now what I want to do is just cover next steps briefly. I really want to emphasize that you take away what you've learned here and you use it to generate ideas, you know, at your site. You know, share them with your team and go out and implement them. You're not going to save anything if you don't implement this stuff. So get going on that. Think about persistent strategies in particular, because these kinds of changes are prone to being undone. So you have to be careful on that part. Bounce your ideas off of PGE and Energy Trust of Oregon, and you can contact PGE for, you know, free consultation. All right, so at this point I'm going to turn the presentation over to Beth for some more information. Thank you.
Thank you, Dave. And Dave mentioned contacting your PDC and the Energy Trust, and if you have questions and you'd like an energy consultation or to be directed towards the Energy Trust and the PDC that applies to your area, and I'm sorry, PDC stands for Program Delivery Contractor, and essentially it's just the Energy Trust, so the people that work with Energy Trust in your area. You can contact, if you're a commercial customer, Paula Conway, and her number and email is here, or Stacy Milliman, and she's for industrial customers, and you're feel free to use that information there. And before I proceed to the question and answer portion of the webinar, I'd like to remind you to continue to submit your questions to me through chat, and I will ask them of Dave. And now, Dave, it looks like our first question is, how much energy can be saved by fixing compressed air leaks?
Okay, that's a good one. I mean, a compressed air system, you know, it's common that, you know, 20 to 30% of the energy use in that system is feeding leaks. You know, that's not unusual at all. It can be as extreme as, you know, half of the energy use, but often 20 to 30%. Saving 10% of your energy use on the system is, you know, that's very doable. So hopefully that gives you a number that you can use to help justify it.
Great.
Thanks.
It's a big percentage. How often should we conduct a compressed air leak sweep?
Yep. Also a good question. I mean, we usually recommend if it's a smallish facility, at least try to do it quarterly. If it's a larger facility, you might do part of the system every quarter, but try to get it through all of it in a year. Because really, once you get beyond that, I mean, some of those leaks will have either reformed or certainly new ones will have reappeared. So I'd say a year at most.
That's great. Let's see, our next question is, what is the typical payback for O&M projects?
Yeah, and I kind of touched on this earlier. With those Energy Trust incentives of 90%, you can get paybacks down to just a few months. I mean, it takes you 3 months to implement it. You get your 90%, and you're there. It's all paid off. You're saving money from beyond that point. Having them down at a year or so is very common. It's often very short, shorter than capital projects.
That's amazing. 90%. Next question is, how often should we calibrate our gauges?
Yeah, I would target, quarterly would be great, and I'd say a year at the most. One thing I would do on that is, if you got something that's hard to reach, and it's hard to calibrate, but doesn't have a big energy or operation impact, well, don't worry so much about that one. But if you got another one that really matters, then get to that one and be more diligent with it. Try to prioritize them.
Great. We have a question that just came in. What can we do to improve persistency of savings?
I think on persistence, one of the key elements is to engage your team. If upgrades are being made by 1 or 2 people, and they're the only ones who know about them, you're prone to having someone else, return the operation to where it was before. So work with the team. Do them by committee. If it's something that we touched on, SOPs and revising those, I've seen some excellent, signage. I've seen people put signs up that show, this is where we put the set point, and this is how many dollars per year it saves us. And they just slap that on a piece of equipment right by the switch that people used to, move to a less efficient position. Someone goes and sees a sign and they think twice about it. So you can get creative with that.
Yeah, and I'd just like to add here that we do have a workshop next week called Employee Engagement and Energy Efficiency, and I've sat in on that in the past, and it's a great place to get ideas for how to get your staff to continue on with behavior or start new behavior. I've heard some really awesome ideas from different participants in that. And Dave, looks like our last question is also a compressed air question. We have an air compressor which runs in modulation. Other people tell me that we can't run the compressor in load unload, and I don't understand why.
Yeah, so that, back to that graph I showed you earlier, where air compressor that's in modulation that's the least efficient. And if you can run it load unload, that's going to be better. And what might prevent you from being able to do that is your receiver capacity. So, how big is your receiver that's storing the compressed air? And if your system, out where you're using the air, is swinging around, and you've got a load-unload machine, it's going to unload, and then, when the system calls for more air, it's going to load right back up again. You need a big enough tank so that you don't have it swinging around. And either, your compressed air vendor or your program delivery control, your PDC can help you with what the right amount of volume should be for it.
Thanks, Dave, and thank you all for joining us. That was our last question.